Hello, my name's Neil and welcome to Recto for You. Today we're going to be building another one of these. Now remember, I built one of these, the Harlequin, and I tried to fix it and it went totally wrong. On the heat plate, there was too much heat and the sockets melted, etc, etc, and it became a mess. It never worked anyway, so today I thought we start a new one, and now I have better tools to troubleshoot this, so hopefully we're going to get one working today. So I'll see you after the short intro and quick word about our sponsor, and we'll crack on. So this is just a quick word about our sponsor. Please visit his website, pcbway.com. They do boards as little as $5, and also they do PCB prototyping, assembly, CNC machining, 3D printing, to name but a few. Really great company, really great service, fast shipping, and the quality of the stuff is second to none. So please have a look at this webpage when you can, and also sign up through my affiliate link below. That's it for now. Let's crack on with the video. So I've decided today it's a bank holiday weekend. The sun is shining. I thought, what a better thing to do. I've recovered from the COVID. I'm feeling very well now. I'm feeling much better now. So I thought, let's just do something relaxing. I sit in the shed while the sun's shining through the window and we'll build this Harlequin up, which is a ZX Spectrum clone. Now, remember a few months back, I did actually build one of these, but when we came to power it on, I've already displayed an image. It was constantly scrolling, and I changed loads of chips, etc. It wouldn't work. So in the end, I thought I had this great idea. So what I did was I turned the heat plate on and I stuck the board on the heat plate, and I thought I'd be able to pull all the components out. It didn't work quite well. This is how it ended up. Ended up a mess, basically. So I decided to scrap that board. I've pulled off what I can. I've repurchased new parts, etc. and going to give it another go. Now, like I said before, hopefully this will work this time round. If it doesn't work this time round, then I don't know what I'm going to do to it. I might end up throwing it out the window or something. So bear with me, guys, and just listen to music while we crack on with this. So that's all the resistors done. Hopefully it's going to work this time. What I can suggest as a tip, what I didn't do last time, was solder these through the top. It's a hell of a lot easier to just feed your solder through with a flux from the top. I'm going to try to do that with as many components as I can, and then just basically flip the board over and cut off the excess leads. So now we're going to carry on with the capacitors. So let's crack on. Okay, so you can see now it's taking shape. The caps are in as well now. There's quite a lot of caps. So next what we're going to do is we're going to do some connectors along the back, some diodes around here and here, etc., and also some transistors along this side. So let's crack on with that as well. So here we are. This is the main turn on again. So let's just see what's going to happen. I'm going to switch to the video grab software because I've got the output here straight to the video grabber. So I'll just switch to that. Transition across, and we'll just turn it on up here. And to joy, we've got no signal. Now, for some reason, it doesn't work again. So I just spent all this time building this up and it's not working again. But unlike the last time, I have now ordered an oscilloscope. So they've got an oscilloscope on the way, which should help diagnose this, hopefully. So let's see how we can get on with this in the next few days. So we're back again. Now, thanks to Captain Commodore, big shout out to him, I actually sent him one of these boards to build up. And he built it all up, and lo and behold, it didn't work. It did exactly the same as this. There was no image, nothing. So what we did, we sat down for a few hours together and he came up with something. He said, I've noticed something. So this is what we noticed. So we're going to try and show you this now. Now, I need to try and work out how to put the oscilloscope onto the screen. So just bear with me a minute and see if I can sort this out. So what we discovered is here we should have a 28 megahertz signal, clock signal. And then that is basically cutting two, etc. until it gets to 3.5 at the CPU. Now, you can see there is a clock signal. And if I click the measure button here, now I'm still new to this scope. I can't even get it working through the windows at the moment, so that's why I've got it like this. But if I see here and click there, I think it's a measure button. There you go. That is running between 19 and 20 megahertz. That should be 28 megahertz. So something is wrong there. So that then cuts down and cuts down and cuts down. And where we should have half a 24, which is like 40 megahertz, we've got 10 instead. So that is wrong. And if we just check on the CPU now, which I believe is pin 6, we do have, again, we do have a signal, but let's click measure. This should be 3.5 megahertz and it's at 2.6. So again, this clock is all wrong, but it does show that the CPU is running, which is good. We've got a clock signal, which we couldn't tell before without the oscilloscope. So I've only just bought this oscilloscope. I'm still learning how to use it. So you can see we're actually getting somewhere now. So what I thought is U13, where the 28 megahertz starts here, I've got a Texas Instrument. So what I decided to do was to order some different ones. Here, and these are the ones I've ordered, which are HLF. So what we're going to do, we're going to stick one of them in and see if it makes any difference. Pop the Texas Instrument out. I'm going to watch this. So I've now added the video output just in case it comes alive. And we're just going to, again, turn it on. And we're going to probe that signal again. Just pin 3. And again, it doesn't seem to have changed. You can see that. I don't know if you can see on that. It's 20 megahertz again. So there's another thing that was suggested for me to try. So just bear with me. So the other thing that was suggested was to try a 74 HCU, which is a faster version of this chip. So what we're going to do now is we're going to stick that in and see if we get any difference. So out with a HLF. So this is a HCU04. Like I said before, it's a faster chip. And that's in its socket, right? So we'll just turn that on. And straight away, look at that. We've got an image. Now, it's purple. It doesn't look good. But let's just check the clock speed on this one and see what we're getting. Also, as well, I don't know whether you noticed, but for some reason, when I try to measure this, it turns the Harlequin image off. So, for some reason, it's affecting it. So, unfortunately, I'm unable to measure that, but it looks like it's running a lot better because we've got everything there running, apart from, as you can see, it's all purple. Let's just stick that into full screen. So it is running and it's in purple. So what we need to do is to look why it's in purple. Now, I'm going to pull the schematic up and we're going to see where the green channel is. So let's just have a quick look at that and see if we can work out why this is. But we're getting actually closer, guys. Buying this scope was worth it. So let's see what happens next. Let's carry on with diagnosing this and see if we can get it in full color. So we're here on the Harlequin screen. Hopefully you can see this. And what we need to do is, you can see here, right, here's a green signal here. So it comes out of this AD724 here. So it comes out and goes to C23. And after C23, we follow it around and it goes to resistor R38. And then from the other side of R38, it goes down to the leg on Q3. So looks to me like what we're going to do first is we're going to check we've got continuity between pin 7 to the capacitor, and then from the capacitor to the resistor, and then from the resistor to Q3. So we're just going to do that first and check that they all have continuity. So that just seems the easiest way for diagnosing this at the moment. And then obviously it goes off through R20 out through pin 4, the RGB socket. Now I have checked my SCART cable. It is perfectly wired, okay? So I thought that might be a problem. It wasn't that. So what we're going to do is we're just going to do that, like I say. And let's see what we find out, if anything. We're just going to try and beat this out. Pin 7. Capacitor there. There you go. So that one is good. And we need to go from that capacitor here to that resistor. So that is good. This plays up a bit. So next we need to go from the other side of this resistor to this leg on Q3. There you go. We have no continuity. So somewhere between this resistor and this leg on Q3, there's a break. So what I'm going to do, I'm going to put a piece of wire across here now for today, a patch wire from this side of the resistor to that Q3, and see if that fixes it. So the soldering iron is turned on. We just need a thin piece of wire. As it's green, shall we use some green wire? Gonna put this wire in. Patch wire. I could One side done there, and the other one to the transistor. Like so. So, that's it for now. What we're going to do is we're just going to pause that, switch. So, we're just about to turn this on, and let's see. So, there you have, full colour. That is absolutely brilliant. So, the green is now back. It's running through its tests. All seems to be working. I've got the case here to fit it into, which is a Spectrum case, and we'll get the keyboard on, and we'll see if we can load a game on this thing. This is really, really good feeling because this is the second one of these I've built. Probably the first one was really nothing wrong with it. It was down to that chip, but as you saw before, that's long gone. So I'm glad this is working. We're going to get the keyboard set up on it. We've got the memory working. It seems to be passing its tests. And the green colour is working now thanks to that little bodge wire, but it's a bodge wire between friends. So we're going to get that installed in the case and try and get a game loaded at exciting times. Okay, so this is where we're at. Unfortunately, I can't load a game on this because this key isn't working here, you see. I can go down to 48 basic. I can type load, but I can't get the inverted commas to work. Now, I've been on the diagnostics and you can see it's when I press number 2, although everything all seems to be working. Almost. There's a few keys that don't. And I've checked online and apparently there's another chip I need to change for an LS. Now, unfortunately, I haven't got one of those. So I'm going to leave the video for now. You can see we're working a lot better than what we were. And I'll get that LS chip loaded and hopefully put into here. I've checked the resistors right around the resistor bridge, etc. I can't really do any more about that, unfortunately. It's a shame. I want to see this thing load a game. But that's about it for now. So I'll see you on the outro. So that's it. We made it to the outro. Unfortunately, again, as things always seem to happen, we didn't fully succeed in doing what we wanted to. But we're a hell of a lot closer than we've been with this Harlequin. All we need to do now is sort that keyboard issue. I've got the chip on order. Hopefully that will come. I'll pop that in and we'll see if it works. And then we'll get some games loaded and we'll upload a video on it and see how it runs, etc. So we've got a Amstrad on the way. We've got an 086 Amstrad to fix up, etc. and have a play with. It's even got a hard drive in it as well. So it'll be interesting to see what's on that hard drive if we get it going. I've also got the Amiga, obviously, which I'm building, the Amiga Plus 500, but there's also the Amiga 1200 build. I've got plenty of projects on the go, but I just wanted to try and knock some on heads. Now I've got an oscilloscope. I've still got to learn how to use it, but we're getting there. We should be able to fix a Jagger as well with that video signal. So I'm going to end the video there. That's it for now. Don't forget to like and subscribe, and I'll see you next time. I'm Retro for you. See you soon, guys. Bye.